Hello everyone, welcome back to my channel. Today is going to be a different topic. Today is going to be a topic we might not cover in AP Physics 1 or any other AP Physics course. Today is going to be a topic which many people do not understand the logic behind it. It's going to be a very short video, but it's going to give you the ideas of what theory of relativity stated. What was the theory of relativity? Everyone keeps talking about it as if they know it, but many people don't actually know the basis of theory of relativity. So basically, relativity talks about how your mass changes, how the speed of light is constant throughout, how you could you can time travel, and how even when you run so fast, so when you run too slow, your mass doesn't change, but when you run at the speed of light, your mass changes. So today I'm going to give you a brief description about how the theory of relativity by Albert Einstein applies to physics. Okay, so let's start with the video. Let's start with the equation. Okay, so the theory of relativity states that your mass at some certain velocity, mass with some certain velocity is equal to the rest mass. The O stands for rest. Your mass at rest, it's not moving, over root 1 minus v squared over c squared. Okay, so mass with some velocity is equal to the rest mass. This is rest mass over, this is velocity, some certain velocity, over speed of light. C is equal to speed of light. Okay, just to mention, C is equal to 3.0 into 10 raised to power 8 meters per second. That's the speed of light. Okay, so now I'm not going to do anything more with this formula. I'm just going to explain how your mass can change with the speed of light. Okay, suppose I'm going to explain two situations. The first situation is if your rest mass remains the same, which is your normal mass when you're not moving, and you're moving at some certain velocity, this velocity, if that velocity is equal to the speed of light, suppose your velocity is also 3.0 into 10 raised to power 8 over 3.0 into 10 raised to power 8, which is speed of light squared. This number divided by this number will give you 1. Alright, so when I plug in 1 into the equation, m with some velocity is equal to mo over root 1 minus 1. So mv is equal to mass O over 1 minus 1 is 0. The root of 0 is 0. So mass over 0. And we know that any number x divided by 0 is equal to infinity. So any number divided by 0 is equal to infinity. And that states that if your body is traveling with some certain velocity, it will equal to infinite mass. So if your body is traveling at the speed of light, your mass will be infinite. You will constantly keep adding mass. Your mass will never get over. And that's why you need infinite amount of mass to travel at the speed of light, because infinite energy is equal to infinite mass, as stated by the E is equal to mc squared, which I'll be explaining in the next few videos. So you need infinite energy to travel at the speed of light, and traveling at the speed of light requires you to have infinite energy. And when you travel at the speed of light, you have infinite energy. Alright? Okay. Now, this is the first situation. When you're traveling at the speed of light, you have infinite mass. That's the first idea. That's the first ideology. Now, moving to the next situation. If your velocity is very small compared to the speed of light, take your velocity as 50 meters per second, and divided by the speed of light. Very small compared to the speed of light. If your velocity is very small compared to the speed of light, this relates to this, what this full thing is. If you take its velocity in meters, 50 meters per second, this value will be very close to 0. Very close to 0. Because 3.0 into 10 raised to power 8 is a huge number. It's a huge number. And when you square it, it becomes even bigger. So this divided by this will be very small. It will be very close to 0. It might be like something like 0.000000001. So it's very close to 0. So you can almost neglect it. You can almost say that it's 0. Okay? So now v squared over c squared is almost equal to 0. Suppose you take it as 0. Then mass at some certain velocity is equal to mass at rest over 1 minus 0, because v squared over c squared is equal to 0. And so with this we can say that any number divided by 1 is equal to that number itself, right? So mass with some certain velocity is equal to mass O divided by root 1, which is also equal to mass O over 1. So if you're traveling at some certain velocity, so what does this basically state? mv is equal to mo. So if you're traveling at some certain velocity which is very low compared to the speed of light, your mass will remain the same. Now what do I mean by this? Okay, suppose I travel at the speed of 80 meters per second. Am I going to lose any mass while running? I won't lose any mass while running, right? I won't lose any mass while running. And that basically states that my rest mass, that my mass when I'm standing will equal my mass when I'm running. But that doesn't work when I travel at the speed of light. When I travel at the speed of light, my mass becomes infinite, way more than my rest mass. Way more than my rest mass. But that's because I'm traveling at the speed of light. If I'm not traveling at the speed of light and I'm traveling at some other velocity which is not really big compared to the speed of light and is very small compared to the speed of light, by going by the ideology that this number, you take it as 0, you can neglect that 1, you can neglect it because the number is very small, it's very close to 0. You can neglect it and say that it's 0. And that basically states that my rest mass will be equal to the mass I'm running with. So that's basically the theory of relativity, and goes by the formula, this formula. This is the theory of relativity. Alright, that's all for today, and I will be coming in with my next video. I'll talk a little bit about E is equal to mc squared formula. This formula is based off the theory of relativity. Everything from this formula almost comes with theory of relativity. So the next video I'll be talking about it, and the next video I'll show you how to derive that equation. How he literally derived the equation, how Albert Einstein literally derived the equation. Alright, that's all for today. Have a wonderful day. Keep sharing, liking, subscribing, and moreover, just comment in the comment section what you think I should improve on, and just let me know if you need anything else. Guys, all the best. Enjoy. Just go.